This is N Lowe and the Harke Group. Norman has had 51 years in the industry, has been involved in all aspects of technical service, through pure R&D through to sales and production. He spent 23 years involvement in soluble packaging and has been a key formulator at Chemlink Speciality groups for powders and liquids into the soluble packaging format. He's now started taking a similar role in his new company with his new owners, Harke Chemicals. Today, Norman's going to be talking about formulating cosmetic products into soluble packaging, reasons and problems.
Okay, good afternoon, everybody. I hope you're all coping wherever you are with lockdowns and things of that nature. My talk this afternoon is on formulating cosmetic products into soluble packaging, but it'll also cover what soluble packaging is and why it's has an eco-friendly position, and the reasons for going into cosmetics and a lot of the formulation challenges that this causes. Okay, so first of all, I was introduced there just to reiterate the things. I've been about 51 years in surfactants, either as technical service or research, and in some cases sales. But also, but mainly as a formulating chemist, and that's my area of business. For the last, I've been with Chemlink Specialities for 23 years, and about 20 of those years, part of what I do, not all of what I'm asked to do, is to formulate products into soluble packaging. This has been mainly into the detergent industry, and certainly and mainly then into the industrial institutional cleaning industry. However, after probably the last 5 or 6 years, I've been taking a greater interest in the possible cosmetic applications of this packaging system. I'll not be showing any formulations as I'm working with under a lot of NDAs in this area, but I think I can explain the reasons why it's a worthwhile area from a green point of view, from an eco-friendly point of view, and the possible problems involved in trying to formulate into this area. So, products in why soluble packs and what are they? Products in soluble packaging have been with us for many years, mainly in the detergent industry, and you will have seen formulations for laundry pods and also dishwash pods in the main. These have many advantages. They give you unit dosing, reducing overdosing, so less waste of chemicals. There's no contact with people. It's protecting people from concentrated chemicals in effect. It's a concentrated format, so much less space for storage and transport. This comes in one of the earlier talks. We're talking about the supply chain and the amount of energy that's used in that supply chain. This reduces that side of the business quite considerably. So you get great energy savings. And of course, probably the biggest ecological advantage that's obvious is the huge reduction in single-use plastics. If you go around any supermarkets and look at the cosmetic shelves, the numbers of shampoos, body washes, etc., hand cleaners, etc., in plastic containers, all of those single-use products, low active products, and a massive reduction in, or possibly a massive reduction in all of those areas. So make no mistake, as far as I'm concerned, plastics won't disappear overnight. I don't think there's any chance of that doing that. Reducing it is, I believe, going to be a many-step process, and I think the soluble packaging area is one of those significant steps which is possible. So the predominant material used for water-soluble packs is of course polyvinyl alcohol, which is very water-soluble and readily biodegradable. I noticed a question earlier when someone was asking whether something was biodegradable. Biodegradable has lots of different definitions, and you should be very specific about what you're looking at when you say something is biodegradable. Ready biodegradability means that really it's not going to hang around very, very long in the environment at all. It's going to be fully mineralized fairly rapidly, or pretty damn rapidly, and may not even get past the sewerage systems to get actually into the water course. So you're leaving no waste. It is, however, a petrochemical derived product, but as we've seen earlier, we're talking about overall savings in plastic single-use bottles, and also in the energy used and in the supply chain systems. But naturally based films are being produced. Again, one of the previous talks showed that that's well on route is producing bio-based polymers. There are already bio-based films out on the market. They're a little expensive at the moment and not quite refined enough, but I'm sure very rapidly over the next couple of years, those replacements for PVOH will come into play. And you might as well start now if you're going to develop these formulations, because the formulations that goes into those systems will be just as relevant for the bio-based films as in these. Okay, so for the ecological impacts, so just to give you some comparisons on the reduction in plastic single-use materials, we looked at a ready-to-use surface spray cleaner in a 500 ml plastic bottle, for instance. By moving to a concentrated soluble pack product, you would save around 20 kilograms of plastic per cleaner per year, which is a huge reduction in single-use plastic. And you reduce warehousing and transport considerably, as said earlier. For instance, one pallet of a powdered concentrated pod for a surface cleaner is equivalent to a 20-ton truck of RTU cleaners. So the supply area is reduced dramatically. So having said all that, why cosmetics? Well, as I said, the main use of soluble pods has been in the detergent industry, and the industrial institutional cleaning industry has taken to it in a big way, and is shown great reductions in the single-use plastic. So, as I said, the detergents either in liquid or powder concentrate form. So why not cosmetics? It's a big area. There's a massive area of plastic usage and single-use plastic usage, and is an area where this could make a fairly significant difference. Single-use packaging is just as big a problem in cosmetics. In fact, it's possibly more with transport, etc. So I started to look at this at least 5 years ago, but I've concentrated in this area for the last 3 years. So problems. So if you're coming around to actually developing products into cosmetic products into water-soluble sachets, so the first universal problem, whether it's cosmetic or otherwise, with soluble film, is of course water content. In general terms, we aim for a maximum of around about 5% water in any system. Any more, and you start damaging the film. This, of course, gives you a lot of formulation headaches immediately as you look at the standard makeup of cosmetic products and the concentration of the marketed raw materials. I'll leave that bit for a second. So, that's one more. Right. So, in cosmetics, so Pictures shampoo, yeah, next slide, pictures shampoo, yeah, right, okay. The next problem is concern is aesthetics. We split cosmetics roughly into two camps, and I say roughly, very roughly. I'm sure people will look at other bits and pieces, but we split them roughly into two camps. You've got leave on and wash off, just two main areas. So the main wash off types, for example, are shampoos, body washes, hand washes, etc. Both foam, foam bath is a slightly different one, but it's all those products have more or less the same aesthetic position, if you like. They're all viscous liquids with a pretty set level of activity. So you're talking with shampoos and body washes, usually in a mainstream would be between 10 and 20% of active materials in a shampoo or a body wash. There will be others outside that, but that's the main sort of area. So they all have very nice color and fragrance and a strictly controlled preservative function, as has been alluded to earlier, and level. The products are all high foaming in this sense, give you control cleaning, and may have other attributes like conditioning, for instance. So one sec. Yeah, so that was it. Yeah, so sorry about that. I didn't get a picture of the shampoo pod for you to look at, but no, you'll have to just imagine that one. So you have to make a concentrate if you want to move into the area of wash-offs. That can be diluted down to the activities above. That in the diluted form has the correct level of fragrance, color, and preservative, and in the concentrate less than 5% water, and must in the diluted form have the same rheological aesthetics as the standard product. The concentrate needs to be fairly low viscosity for filling into film. That's a given. It has obviously got to thicken on dilution to the required activity. So when you dilute it down to that sort of 10 to 20%, it has to thicken or give you the rheological appearance of the product that just sits on the shelf at the present time. This is the tricky bit, and it's only really possible at the moment anyway, by specific surfactant interaction. And matching those interactions with surfactants most useful in a wash-off formulation. So there's no point in looking at product surfactants which aren't normally used in shampoos, body washes, etc. So that are the right price, activity level, and is by far the major problem. Of course, the water content of the concentrate is another limiting factor to the raw material choice. I said, I come back to this, if you look at the surfactants normally used in rinse-off applications, you will see that not many have activity over 30% activity, i.e. 70% water. Formulating these products into a concentrate with only a maximum level of 5% means you cannot get enough in to give any performance on dilution. It would be much easier if the raw material producers look to produce much more concentrated products if physically possible, or use glycolic solvents to replace the water in some of the cases. These are possible. I've been involved in producing these in the past. So if you can produce surfactants, take note. Is it possible, you may ask? Yes, but compromises have to be made, and formulations look decidedly different to the ready-to-use products which are on the market now. But formulations I've developed do perform in a very similar way and look very similar. Skin creams. Leave-on applications are a different problem in many ways, but very similar in others. Raw materials in a skin cream, like emulsifiers and emollient oils and esters, are for the most part high active, low or no water containing products. However, we still have the difficulty of thickening on dilution. We know the ingredients we would normally use to produce a hot blended cream, but they're out of the question in this area. We also know the ingredients needed to produce cold blended so-called gel creams. However, again, the normal polymer types or powders, which may need which are not soluble in oils or low water containing systems, as their normal mode of action is to thicken high water containing systems. And producing a stable liquid, i.e. no powder dropout with these normal products is again seemingly not possible or exceedingly difficult. And you may think, well, let's use a powder system. I can tell you that I've looked at powder systems, and I'm still looking at powder systems. They do present a lot more problems than they cure, but it is an area of R&D that I'm continuing along. But all is not lost with the creams. I found more than one way of achieving this that produces a fully formulated cream on dilution from a water-soluble pod. The concentrated base is also compatible with PVOH film. I showcase this, that's my hairstyle with before lockdown with no beard. But it's so I showcase this at the Laura Marshall Awards at the 2018 SCS Formulating exhibition. This is a 5-gram pod, it dilutes down in 50 mils of water, so 10% in effect, and gives you a with a 30-second shake, and that's the only energy that's put into it is to shake the thing for 30 seconds to produce a fully stable formulated emollient cream. If you look carefully at the picture on the left, you can see the little pods sat in the these were sort of R&D pods sat in the jars there. You just add water to that, shake, and away you go. You end up with a nice formulated skin cream. That was a wonderful flyer my marketing people decided that they would put out on this. But if you're and it's still a viable option, and I've been working further on this over the last 2 years. So other challenges, other problems to give here. Obviously, we are producing products that are at least 95% active, that are diluted to use level. This causes some other problems. Firstly, the preservative level has to be in at a level that is sufficient in the dilution. So this means a large percentage, in most cases, of a water-free preservative is contained in the concentrate. This has effects on film stability and may also affect pack labeling certainly of the concentrate. The fragrance also has to be in a concentrated level. Fragrance is very important, obviously, in cosmetics. And this may obviously be damaging to film at the levels that you've got it in, so it's in the right level when you dilute it down. And it has to solubilize in the dilution with simple shaking. You haven't got any major mixing here. You've just got to shake the thing in a bottle. So you have to make sure that the fragrance will actually go into the diluted product. Dye stuffs have similar problems. These are mainly concerned with the effects of concentrated surfactants causing instability of the dyes. Again, they have to be soluble in the concentrated dilution. They have to be picked very, very carefully so that they're both stable in the concentrate and stable in the dilution. Stability testing of products from all that is obviously doubled. The stability in the pod of the dyes and fragrance has to be tested, as well as the effects on the PVOH, and the stability of the dyes and fragrance and everything else needs to be assessed. The dilution as well, along with the biological stability, which is obviously the usual 28 sort of day challenge test that most cosmetics have to go through. Although again, in this is not a normal product. The dilutions are not going to sit on a supermarket shelf for months. So does it need the same level of preservation? It's an open question yet to be answered. So the standard aging systems, if you're going to go down this line, you're talking of doubling that. So, conclusion. Formulation cosmetics into water-soluble film is not easy. There are many pitfalls, and really need combining experts in PVOH film and surfactant formulators who are experienced in formulating into film. Having the formulator and the film experts in the same company is, of course, an advantage. It would be also advantageous if surfactant producers were to look at concentrated versions of some of their surfactants, if physically possible. Would make future formulating much easier. And I predict the market will grow rapidly in the coming years if the response I'm getting at the moment is anything to go by. The possible advantages in reducing single-use plastics rapidly now is there, and making it really worthwhile goal. It will require R&D chemists. It will require R&D chemists to think way outside the box and expand their knowledge, not just as into surfactant interactions, but also into the film or the soluble films that you can use, either synthetic or natural. I hope this has shed some light on the area, and I thank you for your attention.
Thank you very much, Norman, for an interesting talk. We have one question so far. Three questions are flying in. The first question is, when thinking about laundry, there were new regulations that came in some years ago asking for the dose per wash to be improved, so therefore triggering a higher concentration of the product to keep the same wash efficiency. Is it therefore still now more sustainable to use pods compared to a bottle?
Yeah, you can argue this. It's certainly it's down to formulators, basically. Yeah, and how good you are at formulating these products. Certainly, what you're getting now on the market are multi-pocket pods, and within that multi-pocket pods, you're getting all the ingredients that you used to get in probably either a single powder, which then give you the rest of that performance. So if you look at the sort of P&G pods coming out at the moment, and or auto dishwash pods, the finished products, etc., they're all multi-pocketed pods, and you can put various incompatible things into those different pockets, so that you are getting an overall performance which is wildly increased. To get all the performance in one pod is a much more difficult option, and obviously I'm only sort of putting this out there. I mean, cosmetically, you could actually look at multiple pocketed pods to do the same thing. So it's people to look at this as an R&D adventure, if you like. Go out there and think outside the box, see what is possible, because it does reduce the single-use plastics quite dramatically, and makes life a lot of reduction in energy.
Yeah. Another question from Malcolm: how do the sensory properties of the pod skin cream compare to traditional products?
Yeah, my first position on this was to actually get something that worked. The ingredients in that pod are all normally used in cosmetic skin creams. It is, if you look at the formulation, which well, you won't be able to at the moment, but if you did look at the formulation, you would see that it is a very, very similar skin cream formulation. In fact, all the people that have actually ever tried it have always come back and said to me, that's it really feels absolutely magnificent. It feels like a really good emollient cream. It's only an example. You can adapt this, and I'm looking at this as an R&D position of saying, right, well, if you want to adapt it to any particular application area, like anti-aging or whatever, you would have to then look at the different ingredients that you're going to put into that. The basic problem is getting that viscosity rise, and that is the sort of key to the whole thing. Everything else that you add into that system is up for grabs. It's you know, you can play with that to your heart's content. The objects that in that development for the for goodness shake was to get a decent product that was easily, you know, dilutable, and you could shake into position just with a gentle shake for 30 seconds, which was tricky.
Question from Denise. Norman, I wondered about your mention of using powders within the pods. Could you take your inspiration from powdered beverages where customers is reconstituting the product by adding water to it?
Yeah, it's an area that is looking at, as I alluded to, that it does throw up some problems from a pod. There is a pod. I was looking 2 days ago or last week at a product that's out, I think, on the German market at least, which is a powder in a not in a water soluble sachet. It's in a sort of thin water soluble pack. Which you clip the corner off, you pour the powder into a bottle, add water, shake, and you've got a shampoo system. So that's possible. I've looked at producing some shampoo systems and hand wash systems using powders. The problem you've got with a soluble pods is that viscosity increase, even in powders. Because obviously the products that you normally use to give you viscosity in the powders tend to, as soon as you hit them with water, tend to start gelling. Yeah. If you've got something contained in a pod, by the time the PVOH pod dissolves, you've then got a surface which, if it gels too fast, you end up with one great gel clump, which takes a lot of shaking in. So yeah, I've looked at ways of getting around that, and I think we can probably get around that with a bit more formulating work. So yes, it's a very viable way of going into it. One of the problems again will be your preservative function. It's powdered preservatives, you know, or if you're making a powdered product, one of your problems lies is that your liquid loading onto that powdered system is fairly restricted. Otherwise, the product becomes sticky and doesn't flow, and it's very difficult to fill. Obviously, it's not fillable. So it does throw up a load of other problems when you come to that point, and that's the thing that you've got to start thinking outside the box. That's the way you've got to actually look at this. You know, it's getting everything into the concentrated position that is, in this case, would be a free-flowing powder that would then dilute down and give you the performance and the stability and the safety that you would require from the dilution.
One more question just from me. Obviously, if you've talked about putting the sachets into a bottle and remaking the product, could you go even smaller and have like a single dose? So you put your shampoo in a little sort of sachet on your head?
There has been people throwing these out for some time, and I actually formulated a shower product for South African miners about 10 years ago, to tell you the truth, which was a single pod which you just slapped on your body, and away it went. There is been formulations out which shampoo ones where you just smack it onto the top of your head, onto wet hair and carry on, and also hand wash ones where you can put the pod on your hands, slap your wet hands together, and away you go. There is a problem with this. It's not the actual pods themselves. It's the fact that if you think of a shower product or a shampoo product in a direct use pod, where are you going to actually store that and use it? It's going to be in the bathroom, which is full of water and is possibly the last place on the planet you want to put these products. You know, it will, if there's that much water and steam around, then eventually what you end up with is one big pod or a sticky mess.
Thank you very much, Norman. Any more questions, please go through the chat and send them to Norman. Thank you very much for a very interesting talk. Thank you.
Thank you. Cheers. Thanks, everybody.
Thank you.